Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the video because I have a bonus question for you guys to solve that's similar to this one. So we have 5 to the power of x plus 25 to the power of x is equal to 20. And now what I'm first going to do is I'm going to rewrite this as 25 to the power of x plus 5 to the power of x is equal to 20. So all I did was I switched the places of 5 to the power of x and 25 to the power of x. I did this because it's going to be a little more simpler to have this in a order from higher to lower. So now what I'm going to do is simplify 25 to the power of x by first, because 25 is equal to 5 squared, I'm going to first replace 5 squared with 25. So now I have 5 squared to the power of x plus 5 to the power of x is equal to 20. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 5 to the power of 2 to the power of x, this would equal 5 to the power of 2 times x. And 2 times x is simply 2x. So I have 5 to the power of 2x plus 5 to the power of x is equal to 20. Now what I'm going to do is I'm going to switch the order of these two. So now I'm going to rewrite this as 5 to the power of x times 2 plus 5 to the power of x is equal to 20. And if I have something in the form a to the power of m times n, this is the same thing as a to the power of n times m, right? Then this must mean that if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So this means that 5 to the power of 2 to the power of x, this would equal 5 to the power of x to the power of 2. Now what I'm going to do is I'm going to set the variable y equal to 5 to the power of x. So now by doing that, if I replace 5 to the power of x with y, or I should say if I substitute in y for 5 to the power of x, I get y squared plus, again, we have another 5 to the power of x, so plus y is equal to 20. Now I'm going to subtract 20 on both sides. So now I have y squared plus y minus 20 is equal to 0. Now I'm going to factor this. So y squared, and now I'm going to replace y with 5y minus 4y. So now I have y squared plus 5y minus 4y minus 20 equals 0. And now I'm going to individually group starting by y squared plus 5y, and then I'm going to individually group negative 4y minus 20. So for y squared plus 5y, the greatest common factor here is simply just y. So if I factor out y from y squared plus 5y, I get y times, now y squared divided by y is simply y, plus 5y divided by y is 5. And now from negative 4y minus 20, the greatest common factor here is negative 4. So if I factor out negative 4, I get negative 4 times negative 4y divided by negative 4 is y. Negative 20 divided by negative 4 is positive 5. Now from this, if I factor out y plus 5, I get y plus 5 times y minus 4. And this gives me two equations. I have y plus 5 is equal to 0, or I have y minus 4 is equal to 0. So for y plus 5 minus 0, I simply subtract 5 on both sides, so I get y is equal to negative 5. Now for y minus 4 is equal to 0, simply add 4 on both sides, so I get y is equal to 4. Now remember, we set y equal to 5 to the power of x. So if y is equal to 5 to the power of x, now we have two values for y, so let's first start by replacing y with negative 5. So negative 5 is equal to 5 to the power of x. And this equation actually can't be solved because any number to the power of any exponent can't be negative. So this equation has no solution. Now for y equals 4, simply substitute in 4 for y, so I get 4 is equal to 5 to the power of x. Now what I'm going to do is I'm going to take the log on both sides. So I have log 4 is equal to log 5 to the power of x. Now important property of logarithms is that if I have something in the form log a to the power of b, what I can do is I can move this exponent b to the front of the logarithm times log a. So for log 5 to the power of x, I can move the exponent x to the front of the logarithm, so this would equal x times log 5. So now I have log 4 is equal to x times log 5, and now I can divide log 5 on both sides. So now log 4, this is equal to approximately 0.602. Log 5, this is equal to approximately 0.698. So now I have this is equal to x, and 0.602 over 0.698 is equal to approximately 0.861. So x is equal to 0.861. Now I'm going to be teaching you guys how to, I'm going to be giving you guys a practice problem, and you guys have to use the techniques used to solve this problem to solve the problem I'm about to give you guys. So the problem I'm about to give you guys is 3 to the power of x plus 9 to the power of x is equal to 90. So I'm going to ask you guys to pause the video and try to solve this problem. Okay, so to solve this problem, I'm going to first rewrite this as 3 squared to the power of x plus 3 to the power of x is equal to 90. I can rewrite this as 3 to the power of x squared plus 3 to the power of x is equal to 90. I'm going to let y equal 3 to the power of x. So now if I substitute in y for 3 to the power of x, I get y squared plus y is equal to 90. Now I can subtract 90 on both sides. So I get y squared plus y minus 90 equals 0. Now I can rewrite this as y squared plus 10y minus 9y minus 90 is equal to 0. Let's first start by factoring out y from y squared plus 10y, so I get y times y plus 10. Now from negative 9y minus 90, I'll factor out negative 9, so I get negative 9 times y plus 10. Now if I factor out y plus 10 from this, I get y plus 10 times y minus 9 is equal to 0. This means that this gives me two equations, y plus 10 equals 0 or y minus 9 equals 0. For y plus 10 equals 0, I subtract 10 on both sides. So I get y equals negative 10. For y minus 9 equals 0, I add 9 on both sides. So I get y equals 9. Now remember, we set y equals 3 to the power of x. So if y equals 3 to the power of x, now I have to substitute in these two values of y for y in this equation. Let's first start by negative 10. We have negative 10 equals 3 to the power of x. This can't be solved because any number to the power of an exponent can't equal negative number. So now we have 9. We have 9 equals 3 to the power of x. 9 is equal to 3 squared, so I have 3 squared to the power of is equal to 3 to the power of x. This means that x equals 2.